students, welcome to this channel. I am Ringesa, a mathematics teacher at Lux School of Science. Today we'll start with chapter number 1 of standard 11. Chapter number 1, that is sets. Okay, now this is a very easy chapter of mathematics. You had already studied about set in your lower standard. Since standard 8, I think you are studying about sets. Okay, so here we'll study in detail. So first, let's go to the basics. Okay, first definition. What is a set? Okay, what is a set? A set is a well-defined collection of objects. You can say set is well-defined collection. Okay, clear. The word very important here is well defined. That is very important word. Okay, if you want to say that well defined means if you want to, if I am asking you that give me a set of let's say a collection of best players, collection of best players of India. Okay, then will it be a well-defined set? Will it be a well-defined set? No. Say, if I say Sachin, Sehwag, and Ganguly are the best players of India, right? But others might have different opinion. Like someone say Virat Kohli, Dhoni, they are the best players, right? So the best players of India, that is not a well-defined collection. So that is not a set. Okay, but if the question is uh, top five countries or top two countries in population, then yes, it is a well defined collection. If I take top two countries in population, definitely it will be China and India, right? Here the answers cannot vary. So that is a set of well defined collection. Okay, so what is a set? Set means well defined collection of object, that is called a set. Okay, now the next one, representation of a set. A representation of sets. So there are two forms, rooster form and set builder form. Rooster form, also called as listing method, right? You are listing the element in a curly bracket separated by a comma. Means if I say A is equal to 1, 2, 3, 4, 5. So what I did, I listed out the element in curly bracket and separated the elements by comma. That is rooster form or listing method. Okay. The second one is set builder. This is rooster form. Set builder or property method. Here it's listing and here it's property. Okay, now if I want to define these elements, then I can say it as natural number less than 6. Okay, then it will be obviously 1, 2, 3, 4, 5. So property, I will write it down property. A is equal to X such that X belongs to N. Means X is a natural number and X is less than 6. I can also write it down X is less than equal to 5. Right? So this is the property method or set builder form and this is the rooster form. Clear? Okay, now let's move to the next one. Types of set. First is empty set. Now the name itself gives its definition that there is this set is empty, means there is not a single element means this is called empty set. There is a bracket, but there is no element inside the bracket. So this is empty set. Or I can also write it down in this way. 5. This also means empty set. But most of the time, students make a mistake. They consider this is empty. This is not an empty set. Instead, this is our next singleton set. Set consisting of one element, that is 5. Okay, so empty set can be represented by brackets without any element or a symbol 5. Okay, but not in the bracket. Clear? So that is empty set. Okay, now the next one, singleton set. Again, the name itself, single. Single means only one. The set which have only one element means 1, A, 5, -7. These are all the singleton set. See, when it is denoted in the bracket, then this is a complete set. This is another complete set. This is also one of the set, and this is also one of the set. And in all the sets, there is only a single element. Hence, these are single set. Sorry, singleton set. Okay. Next, finite and infinite set. Finite set means in which you can count the number of elements. Means there is an end, right? There is an end. There can be 2 element, 4 element, 100 element, 1000 element, lakh element, million element. But there is a end. There is an end. There is a finite set. Means you can count the total number of elements. Like one, two, three, three elements, or else -99, -98, dot dot dot, 0, 1, 2, dot dot dot, 99. Okay. Again, this is a finite set whose starting first element is -99 and last is +99, right? But infinite set, okay, what is an infinite set? Means you cannot count the number of elements. There is not a fixed number of elements, right? Like this way: one, two, three, four, dot dot dot. There is no end. There is no end on this side. Even this way, -2, -1, 0, 1. Okay. Even this way, these are all the integers. A set of integers is an infinite set. A set of natural numbers is an infinite set. Okay, so if you can count the total number, that is finite, and if you count, it is an infinite set. Okay, now let's move to the next one. Equal sets. Okay, if all the elements of one set are in the another set. Okay, exactly same number, in the same number, right? If set A is having 4 elements, if set B is having 4 elements, and if all the elements in A and B are same, that means they are equal sets. So there are two conditions. First, the number of elements in both the sets must be same, and all the elements in both the sets must be same. Means if A is equal to 1, 2, 3, A, B, 5 elements, B equal to A, B, 3, 2, 1. Again 5 elements. And if you see 1, 1, 2, 2, 3, 3, A, B, B, all the elements are same. So in this case, I can say A is equal to B. Okay. So if all the elements of one element are in B, and if all the numbers of element of set A and number of elements of set B are same, then they are called as an equal set. Okay. And the next is equivalent set. Now, in equivalent sets, all the elements of one set need not be same in the other set, but the number of elements in one set must be equal to the number of elements in other set. That means all the equal sets are definitely equivalent sets, but all the equivalent sets are not equal sets. Means if I'm writing A equal to 1, 2, 3, 4, and B equal to A, B, C, D. See the number of elements in A, 4. Number of elements in B, 4. But the elements are not same. But still, these are called equivalent sets. Clear? And in equal sets, obviously the number is also same. So all the equal sets are called as an equivalent set. But all the equivalent sets are not equal sets. Okay? So this was about equivalent set. Okay, so just these were the about the types of the sets, definition, representation of sets, rooster form, set builder, types of sets, empty set, singleton set, finite and infinite set, equal sets, equivalent set. Okay, now let's move forward. The next is universal set. Universal set is a set that consists of all the objects, including itself, or you can say which includes all the sets in a context. Right? Means if I take U equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then from this, different sets are defined, like set A, number even number 2, 4, 6, 8, 10. Set B, number less than 4, means 1, 2, 3. Set C, number less than 5, 6, 7, 8, 9, 10. So these three sets are defined on the basis of this set. This is the universal set. Okay, so it consists of all the elements including itself. That is universal set. Clear? The next, subset and belongs to. Now here students get confused between subset. This is the symbol for subset, belongs to. This is the symbol for belongs to. Now see subset. What is a subset? If all the elements of set A are present in set B, then A is called a subset of B. Like A equal to 1, 2, 3, and B equal to 1, 2, 3, 4, 5. Now see all the elements of A are in B. That means A is a subset of B. Clear? So by this we can say one thing. Every set is subset of itself. Remember this point. Every set is subset of itself and null set is subset of every set. Clear? Any set, sorry, not belongs to subset. Or I can write down Null set is subset of every set, and every set is subset of U. Okay? Every set is subset of itself. Every set is subset of U. And null set is subset of every set. Right? Okay? Now, what is belongs to? See, when two sets are compared, there will be a symbol of subset. Means here there is A and B. A can be subset of B or A is not a subset of B. Right? But you cannot write down set A belongs to B. Okay, when you use this symbol, you have to use element. Means in this case, I can write it down 2 belongs to A. Clear? See, I cannot write down in this way because when you're writing in a bracket, then it's not an element, it's a set. Okay? Clear? I can write down here 2 belongs to A. Okay? But if a set is like this way, let's say C 1, 2, 2, 3, 4. Now in this case, I can write down that this 2, 3 belongs to C. Okay? But when an element and a set is compared, you have to use the symbol belongs to. Okay, if it is not belonging, like 4 does not belongs to B. Sorry, A. 4 belongs to B, but 4 does not belongs to A. So don't get confused between subset and belongs to. When on the one side there is a set, other side also set, then the symbol will be either subset or not a subset. But when we are taking element on one side and set on other side, it will be belongs to. Okay, or not belongs to. Clear? So this was about subset and belongs to. Next, power set. Power set means if A is a set, then P of A is power set of A. Let's take A 1, 2, 3. Now, what is power set of A? Power set of A is list of all the subsets of A. Now, see, what are the subsets of A? Subsets of A will be null set is subset of every set. Now see, 1 is subset, 2 is subset. See, 1 is, see, on one side 1, other side 1, 2, 3. It will be subset. Right? What was subset? If all the elements of one set is present in second, it is subset. So 1, 2, 3, 1 and 2, 1 and 3, 2 and 3, 1, 2, 3, right? These are the subsets. How many subsets? 1, 2, 3, 4, 5, 6, 7, 8. So these are all the subsets of A. So power set of A is a set consisting all the subset of that particular set. Okay? Clear? But now, in this case, these are the proper subset. Okay? Because null set and null set is subset of every set and set itself is a subset of itself. Right? A set is subset of itself and null set is subset of every set. So these are, if you want to find out the proper subset, then these are the proper subset. Okay? So now if number of element in A, if number of elements in A is equal to n. Clear? The number of element in power set of A. So when I use this symbol in front of before set, this means number of element. If number of element in a set is n, then number of elements in power set of this will be equal to 2 raised to n. Okay? And total number of proper subset. This is equal to 2 raised to n minus 1 and 2. Total number of sets 2 raised to n. If the question is total number of subsets, then this will be equal to 2 raised to n. Means number of element in power set. But if the question is total number of proper subset, it will be 2 raised to n minus 2. Clear? So see here, what is in this case? Number of element in A is equal to 3. So what will be the number of element in power set of A? 2 raised to 3 equal to 8. Just calculate. 1, 2, 3, 4, 5, 6, 7 and 8. Right? And the question is total number of proper subset 8 minus 2. So this will be equal to 6. Okay? So this was about power set. Power set, this is very important concept. Okay? So note down this formulas and also this one. Okay? So note down this. Okay, students, so that's it for today. In our next video lecture, we will see some other basic concepts of cell. Thank you.